Next topic, tautology and contradiction. A compound, a compound proposition is called a tautology if it is true for all possible assignments for its primitive statement. That the statement is compound proposition is true. That is, all values are not then that compound proposition is called tautology. And if the compound proposition is false for all such assignments, then it is called a contradiction. For example, P conjunction uh, negation P is a contradiction. Now, logical equivalence. Two statements, two statements S1 S2 are said to be logically equivalent. We write S1 logically equivalent to S2 when statement S1 is true if and if statement S2 is true. When S1 logically equivalent S2, the statement S1 and S2 provide the same truth value truth table because S1 and S2 have same truth values for all choices for their primitive components. Now, logical implication. If P and Q are arbitrary statements such that P implies Q is a tautology, then P is logically implies Q and we write P implies Q. So P implies Q is a tautology, then we write that P is logically implies Q and it's denoted by P implies Q. When P and Q are statements and P implies Q, then the implication P implies Q is a tautology. Let us do a few easy problems. The first one is if P and Q are primitive statements for which the implication P implies Q is false, determine the truth values for the following: P conjunction Q and P negation P disjunction Q, negation Q implies negation P. So for that we have given P implies Q is false. So P implies Q is false. We know the truth table of P implies Q. P implies Q. So P is true, Q is true, P implies Q is true. P is true, Q is false, P implies Q is false. P is false, Q is true, P implies Q is true. Both false, then P implies Q is true. So this only happens when P implies Q is false only when P true, Q false. That is, values of P is 1 and Q 0. So P 1 Q 0, then P conjunction Q is P Q. Okay. P1 Q 0, then P conjunction Q is 0 because it's false. So that value is false. Now, next negation P. Okay, next I am writing here P Q negation P disjunction Q. So P is true given and Q is false. Negation P is again false. Negation P disjunction Q is false. So the statement is false. Now the next is negation Q implies negation P. So we have P Q negation P negation Q implies negation P. So P is true, Q is false, negation Q is uh, true, negation P is false, negation Q is true, negation P is false, then uh, the negation Q implies negation P is false. So this truth value is also false. So that is it. Similarly, we can do other problems. So another important problem is construct a truth table for the compound statement negation of P distinction Q negation Q implies negation P. P and Q are primitive statements. So the first column P, second column Q, we have P distinction negation Q negation P. So negation Q I have written here. P distinction negation Q is there. Negation, then negation of P distinction negation Q, negation P, and the final statement negation of P distinction negation Q implies negation P. Now, if P is true, Q is true, then negation Q is 0. P distinction negation Q 0 0 0 P 1. So, distinction is 1 and its negation is 0. 1 negation is 0. Negation P 0 and therefore we have these two 0 and 0 implies 0. So both are 0, both are false. So implication is if P implies Q, we know that if P and Q are false, then P implies Q is 1. So this is true. Similarly, 1 0 P1 Q0 negation Q1 P distinction negation Q P is 1 negation Q is 1 P distinction negation Q is 1 and its negation is 0 P negation is 0 negation of P distinction negation Q is negation P, that is true. Similarly we can do all this and the truth value of the final column is all 1. So this is a tautology. Okay. So that is a tautology. Now we will do another problem. So in this problem, construct the truth value table and show that implication P negation P disjunction P implies Q is a tautology. So, P and Q are there. P1 Q1 then P implies Q is 1. P conjunction P implies Q is 1. Okay, 1 and this one and their the disjunction conjunction is 1 and so now P conjunction P implies Q. So 1 is here, 1 is here, so 1 is here. That's 1. Now if P is 1, Q 0, P implies Q is 0. P conjunction P implies Q is 0. Now P conjunction P implies Q goes to Q is 0 0 which is 1. So we know that P implies Q is if both P and Q are 0 then P implies Q is 1. Similarly we can do all these values and we get all values in the last column is 1, therefore this is a tautology. So similarly we can do some other problem. Check whether okay. So next is contradiction. Show that the statement P conjunction negation P conjunction Q is a contradiction where P and Q are primitive statements. P Q. If both are 1, the negation P is 0. Negation P conjunction disjunction Q. Conjunction Q. So negation P is 0, 0 conjunction Q. 0 conjunction Q is 0. Okay. And this is 0. Similarly, P is 1, Q is 0. Negation P is 0. Negation P conjunction Q is 0. 0. So similarly, we will get all these values as 0. Then this is called a contradiction. So then this statement is called contradiction. Similarly, you can do all other problems. There are contradiction and tautology or the other statements. Okay.